Hello and welcome to the lightning talk for the Mask MSD team. In today's lightning talk, I will be giving an overview of our project as the RIT Mask Multidisciplinary Senior Design Team. So a little bit of background on the team. We are, as previously mentioned, a multidisciplinary senior design team. What multidisciplinary senior design is a 2-semester studio course where students are responsible for end-to-end design process. We manage all of the areas of the project, such as the design of the end product, testing it, building it, assembling it. But we are obviously directed by several guides that assist us in this process and are incredibly helpful. On our team, we have 6 total people: Justin Ludis, Gang Chindang, Rhythm Patel, Jacob Rafferty, myself, Junda Ku, and Andrew Doughton. In a little bit more on multidisciplinary senior design, it is a class broken up into many phases. As previously mentioned, it's a 2-semester course, and we go all the way from defining the problem to finally integrating our system, integrating our solution after having built it and tested it and iterated upon it. And at the moment, we are currently finishing up at our system level build and test phase. So I'll go into the progress we have made. So a little bit of background on our project now. So an overview, what exactly does our project seek to accomplish? What does MASK, our team, seek to accomplish? Well, this project seeks to address the lack of inclusive respiratory PPE for all types of hazards and users. What do I mean by inclusive? Well, a lot of the issues with present-day masks is that they're not very accessible to individuals such as the deaf and hard of hearing community, or really to anyone that is trying to be, in a communicative setting while wearing a mask. Can also it can cause muffling, or especially with the deaf hard of hearing community, it can cause an inability to see the mouth and thus read the lips, and that is a barrier to communication. So our end goal is to design and fabricate a prototype respiratory PPE, which both protects the user from harm, so it satisfies relevant guidelines and regulations, but it is also inclusive within a focus placed on enabling communication. And our stakeholders, as so, are obviously the client for our team, general PPE users that stand to benefit from our product, the deaf of hard of hearing community, and various regulatory agencies and other extraneous related organizations that could look at our project and see something that they want to possibly potentially pursue or elaborate on. So how did we go about starting our project? Well, we started at the system design level, and we began that by engaging in a process called functional decomposition. That is decomposing the problem into smaller and more manageable pieces. At the very top, we have our high-level functions. What is our product as a whole, and these higher-level functions, they're very abstracted from the very specific details of how we're going to accomplish this. So some of our top-level functions, such as protecting a wide range of users, as we go down a level of abstraction, what does that mean? It means minimizing respiratory hazard exposure, enabling communication, fitting to the user's face, providing multiple uses. And from there, we go to sub-function concept generation. That is generating concepts that are going to benefit or accomplish each of these higher level abstracted functions. So now looking at the system architecture, this is where we bring in the concept generation. Some of these concepts being transparent screens, anti-fog spray, form-fitting face cushions, adjustable head straps, modular assembly, replaceable filters, circumferential seal, and SMS fabric. What do all these things do? Well, again, let's work down from the levels of abstraction. So we're trying to protect a wide range of users, and we're trying to do our sub-functions here, such as enabling communication and the rest that I mentioned. Well, enabling communication, what do we need for that? We need to enhance vision of the lips and facial expressions. Okay. What does that include? So yeah, we have to provide a view of the face and mouth, and we also have to prevent the inside of the mask from fogging. And that's what the transparent screen and anti-fog spray accomplish. Fitting to the user's face, we have to adapt the diverse facial shapes and structures. So that means we have to conform to the user's face shape, and we have to secure the respirator to the user's face. And again, that includes form-fitting face cushion and adjustable head strap. Ensuring proper and adequate maintenance. That is very important when we want to have a clean mask that works effectively. We need to enable interchangeability and extend the protection duration of the respirator. So that means we need a modular assembly and we need replaceable filters. And filter air inhaled and exhaled by user. That means we need to restrict the airflow to the filters of the mask. We don't want air to bypass the mask or respirator. We want it to go through those areas where we can control what's going to the mask. And of course, block potentially dangerous particles. And these are done with a circumferential seal and the SMS fabric. SMS fabric being a medical grade fabric that's often used for filtering. So going on a little bit more with our system architecture, we look at our actual design. We look at some CAD models for our prototype. So we see here, we're going down from left to the right, full assembly, head straps, face piece body, face cushion, face piece connector and adapter, clear face piece, and the replaceable filter. So the replaceable filter, that is including our modular filter that can be taken on and off. The fabric can be replaced, and the fabric is included in that. The clear face piece is the window, the porthole on the front of the mask that can be seen through, so that you are able to view lips and facial expressions and be able to read those. The face piece connector / adapter, that is a kind of like an intermediary part between the face cushion and the face piece body, something meant to attach the two to one another. And again, this is all in line with our modular design. And then of course our head strap, something to secure the mask to the user's face. We've got to keep it on. We got to have a good fit so that we can restrict airflow. And we also have some tests planned for this prototype, namely 3 essential tests, we believe. Particle filtration efficiency, quantitative fit, and a survey. Okay, what is particle filtration efficiency? Well, there are several, as mentioned previously, several guidelines and standards that we want to achieve. We want to make sure that we hit with the development of this mask. And one of those is achieving greater than or equal to 95% particle filtration efficiency of 3 micron, particles 3 micron or larger. The other one being quantitative fit. This is a fit score of greater than or equal to 100 out of 200. Both these tests are tested in a very similar way. It is using a particle counter in addition to a fit tester. So this is a specialized piece of machinery that we have access to, that we intend to complete these tests with to ensure that we're meeting NIOSH ASTM guidelines and standards. And then lastly, we want to make sure that we survey some of the critical people that we want to target with this project, the people that stand to benefit from this project. So that being, we want to potentially survey the deaf and hard of hearing community at RIT and inquire about the general comfort, fit, breathability, and communicability of our design, and see what needs to be iterated upon from there. But that is the conclusion of our project overview here. Thank you very much for your time, and have a nice day.